What if I tell you the Earth, Sun, stars, galaxies, and all the observable celestial objects make up less than 5% of the total mass of the universe? The rest of the 95% consist of dark matter and dark energy. Perhaps one of the most shocking discoveries and puzzling mysteries of the 20th century. Renowned theoretical physicist Stephen Hawking remarked in 2013, "The missing link in cosmology is the nature of dark matter and dark energy." In July of this year, the European Space Agency launched the Euclid Telescope to capture the elusive nature of dark matter and dark energy. The telescope aims to understand the enigmatic properties of dark matter and dark energy by producing a three-dimensional map of billions of galaxies and other formations in the universe across time and space. ESA has recently released the first full-color images of the cosmos shot by Euclid. What do these shots tell us about dark matter and dark energy, and the universe at large? In today's video, we'll dive deep into the intriguing subject of dark matter and dark energy and look at the fresh findings of the technological marvel known as the Euclid Telescope. Let's get started. Imagine there is an invisible force that doesn't interact with matter, something completely undetectable. It is neither visible to light nor electromagnetic radiation. Yet, without it, the behavior of galaxies, planets, and stars doesn't make sense. This is how mysterious dark matter is. The concept of dark matter has been around since the 19th century, but it was in the 1930s that Fritz Zwicky, an astrophysicist from Caltech, further developed the idea into its current form. While studying the movement of galaxies in the Coma cluster, Zwicky determined that the quantity of matter that could be seen was 400 times less than what was required to explain the observed motion. The visible matter couldn't produce enough gravity to hold the cluster together. Theoretical physicist Brian Greene wrote in his 2004 book titled The Fabric of the Cosmos, "Some of the fastest moving galaxies should have been flung clear of the cluster like water droplets thrown off a spinning bicycle tire." Zwicky called the unseen matter dunkle Materie, which is German for dark matter. Astronomer Vera Rubin and her colleagues conducted further research over the next 3 decades. Their research further solidified the evidence for dark matter. Current estimates suggest that approximately 80% of the universe is made up of dark matter, while the remaining 20% is ordinary matter. So how do scientists know there is such a thing when it is not even visible? Dark matter has not been directly observed by scientists yet. It doesn't interact with regular matter, and it's completely invisible to light and other types of electromagnetic radiation. This makes it impossible to detect with current instruments. However, scientists are certain of its existence due to the gravitational effects it seems to have on galaxies and galaxy clusters. According to basic physics, stars at the outer edges of spinning galaxies move slower than those near the center. This is because most of the matter is concentrated in the center. Observations show that stars orbit at a similar speed no matter where they are in the galaxy. The puzzling result can be explained by assuming that the outer stars are affected by the gravitational forces of invisible dark matter. This dark matter exists in a halo around the galaxy. Dark matter may also offer an explanation for particular optical illusions observed by astronomers in the depths of the universe. One example is when we see galaxies with strange rings and arcs of light. This might happen because the light from faraway galaxies gets bent and magnified by huge dark matter objects that we can't see. This phenomenon is referred to as gravitational lensing. There are several theories proposed by scientists regarding the nature of dark matter. Some scientists think dark matter is made of strange particles that don't interact with regular matter or light, however they still have a gravitational effect. Dark energy is even more bizarre. The discovery of dark energy in the 1990s was a surprise to scientists. They used to think that gravity would make the universe's expansion slow down, yet 2 separate teams discovered that the expansion was actually accelerating. Researchers currently believe that the rapid expansion of the universe is caused by a repulsive force that arises from quantum fluctuations. This is typically considered empty space. Additionally, this force appears to be increasing in strength as the universe continues to expand. Due to the lack of a more suitable term, scientists have labeled this confounding force as dark energy. Scientists currently do not have a viable explanation for dark energy, unlike dark matter. One theory suggests that dark energy could be a new type of fundamental force called quintessence, which behaves like a fluid and permeates the entire universe. The Euclid mission led by ESA aims to investigate the dark universe's composition and evolution. The Space Telescope will observe billions of galaxies. It will look up to 10 billion light years away and will cover over a third of the sky. The telescope's goal is to create a map of the universe's large-scale structure across space and time. Euclid's observations will shed light on the expansion of the universe and the formation of its structure throughout time. This will provide further insights into the nature of dark energy and dark matter, as well as the role of gravity. The mission began on July 1st, 2023, from Cape Canaveral, Florida, USA. The spacecraft was set into orbit using the SpaceX Falcon 9 rocket. The destination of the spacecraft is the Sun-Earth Lagrange Point 2, which is 1.5 million kilometers away from Earth. 4 weeks after the launch, Euclid entered orbit around Sun-Earth Lagrange Point L2. Once in orbit, mission controllers initiated the activities to verify all functions of the spacecraft. They checked out the telescope and finally turned the instruments on. Next, scientists and engineers engaged in an intense 2-month phase of testing. They calibrated Euclid's scientific instruments and prepared for routine observations. The telescope began its early phase of the survey of the universe 3 months after launch. The first breathtaking pictures from Euclid were revealed at the end of October. They showed active galaxies, groups of old stars, and ethereal, dreamy regions where new stars are born. A particularly attention-grabbing image released showcases the Horsehead Nebula, a part of the Orion constellation. This cold and dark cloud of gas is a region where stars are actively forming. It is famous for its unique shape, which resembles a horse's head and stands out against the luminous backdrop of the cosmos. The Horsehead Nebula, which is also called Barnard 33, is around 1,375 light-years from Earth and is recognized as the nearest massive region where stars are formed. The hidden galaxy, also called IC 342, was also detected by the Euclid Telescope. It is a spiral galaxy that is difficult to observe. This is due to the presence of stars, gas, and dust from our own Milky Way that often obstructs its view. Euclid's advanced near-infrared tools have the capability to penetrate dense space dust, providing fresh perspectives on the spiral galaxy. In its first batch of full-color images, the Euclid Telescope captured a cosmic portrait that officials at the space agency called a revolution for astronomy. The images depict the Perseus cluster. It consists of approximately 1,000 galaxies, as well as over 100,000 additional galaxies located at a greater distance. Each of them contain potentially hundreds of billions of stars. NASA states that the Perseus cluster is among the largest structures in the universe. It is located 240 million light-years from Earth and houses numerous galaxies surrounded by an enormous cloud of extremely hot gas. Euclid also observed NGC 6397, a tremendous globular cluster consisting of hundreds of thousands of stars held together by gravity. This cluster is about 7,800 light-years from Earth and is found within the busy disk of matter encircling the core of the Milky Way. According to astronomers, globular clusters are among the most ancient entities in the cosmos. They may provide valuable information about the formation and development of their parent galaxies. Completing this recently unveiled collection of eye-catching cosmic visuals was a photograph capturing NGC 6822, a diminutive and asymmetrical galaxy situated 1.6 million light-years from Earth. These dwarf galaxies are believed to be the fundamental components of larger galaxies. Researchers speculate that similar compact and irregular formations likely existed during the early stages of the universe. The captivating vistas of the Euclid Telescope offer an enticing preview of the potential discoveries that it may uncover during its 6-year expedition. What other wonders of nature will this powerful telescope unfold during its cosmic venture? Space enthusiasts are looking forward to more fascinating discoveries.